when we talk about data, I mean, every query costs money, and the more people, everybody want to be data driven. But the problem is you just are spinning up more things on cloud and running more queries, but you just need to bring what's necessary, right? That's the power. That's why I keep coming back to the array and vectors is you just focus on what's needed to answer the question instead of trying to bring the whole data across the wire.
Welcome to another episode of ArrayCast. My name is Connor, and today with us we have a very special guest. But before we get to introducing him, we're going to go around and do brief introductions from our panelists. So first we'll go to Bob, then to Stephen, then to Adam, and then to Marshall.
I'm Bob Therriault, and I am a J enthusiast, and very enthusiastic about J.
I'm Stephen Taylor. I'm a Q and APL enthusiast, and also the KX librarian.
I'm Adam Brudzewski. I am an APL enthusiast. I'm also enthusiastic about other array programming languages, but I do APL for a living full-time at Dialog.
I'm Marshall Lockbaum. I'm the writer of BQN, but I'm really not that enthusiastic about it. Okay.
And I'm Connor, as I mentioned before. I'm a research scientist at NVIDIA, and I'm an enthusiast of all array languages, and I switch between the ones that I write in day to day. And we have one exciting announcement and then two other less exciting announcements. So first we'll go to Bob for the very exciting announcement, and then we'll go to Marshall and Adam for our two follow-up announcements.
Well, my very exciting announcement, it's actually congratulations to Adam, who's also very enthusiastic about the new addition to his family, a baby girl, who just happened to pick the fortuitous date to be born on of my birthday. So we'll probably be exchanging gifts in the coming years. But congratulations, Adam. That's fantastic, and I hope everybody's doing well and healthy and happy. And I mean, just say goodbye to sleep, but you already know that because I think you've got two other kids.
Thank you. Well, I mean, the important thing isn't so much that it's a girl. I would say the important thing is the future array programmer in the making. So one of the I was active in the various APL chat rooms as she was being born. And I was asking this question, if does anybody have a good first APL expression for a little girl? And people all came up with way too difficult expressions like iota 10 and things like that, or even 1 plus 2, 3. And then Alva was a winner, a previous winner of the APL problem solving competition. He came up with the perfect response, which was a commute or tilde diaresis just by itself. Monadic operator, the one that can either make a monadic function out of a dyadic function by using the same argument on both sides, or flip the arguments around, or it can now be used for constant functions as well. But that expression, just that symbol itself. So I tried that on her with great effect. So it's awesome.
I'm a bit confused here. Did I hear this correctly? You were in APL chat rooms while the baby was being born?
Yeah, of course.
What? Yeah, he was just talking about APL, and then in the middle of it, he said, "Oh, I'm helping to give birth right now."
All right, well.
And then he was trying to answer questions and saying he was apologizing for being slow because he had one hand on a baby and one hand to keyboard with. So it was hilarious.
Holy smokes. Well, for those that think it's difficult to type APL characters, clearly, you can multitask while doing it to the extent that you can, No,
it's quite the opposite. Because these languages are so terse, so brief, you stand a chance of typing meaningful amounts of code while you're assisting with a birth, as opposed to, imagine if it was Java or something. How much code could I produce?
I guess that's a good point. Well, congratulations from all of us. I'm sure... it's going to be an exciting next few months and a new chapter, new journey. And excited to hear updates of the progress of, how many months are we going to expect our first sort of small programs to be written. We'll be waiting to hear. All right, let's head to Marshall for the announcement and then head back to Adam for his last one.
All right. Certainly not quite as exciting. We're, of course, making various additions to BQN. The one I've recently done is something a lot of people have asked for. It's a parser and a serializer for the JSON format, so JavaScript object notation. There's now a library in BQN libs that handles JSON. So you can just, give it a string of JSON data and it'll give you a BQN array out that, sensibly represents what was in that string. And the other way around, you can take your BQN array and serialize it to JSON. I believe it's completely compliant on the parsing. It seems reasonably fast. It's not like SIMD JSON, but it's 20 or so megabytes a second. So yeah, it should be a pretty solid tool and convenient to use.
All right, awesome. And over to Adam for his last announcement.
Well, it's not so much as an announcement as much as a pointer to something that you might find interesting, if you find this podcast interesting. And that is a talk just from a week before we're sitting and recording this. And it's called Change the Way You Write, Change the Way You Think. And it's talking about getting some ideas on changing your thought processes when writing code in general. So I think that's an often overlooked aspect of these array languages, because let's be realistic. The world isn't going to just start using only these languages and discard everything else. But I think there are a lot of good lessons that can be learned from the style of code and the thought processes that are involved in the thought process you learn to have when you're writing in these languages. And so this talk that we'll put a link in the show notes to, go check it out. I really think it's good.
Awesome. Yeah, you can find that link in the show notes as always. And I think that brings us to introducing today's guest, which I'm very excited to be having on this podcast. Our guest is Ashok Reddy, the CEO of KX, which is the company, of course, most of our listeners will know, that is responsible for distributing the Q language and the KDB Plus database. So a little bit of background on Ashok is that he joined as CEO in August of 2022. So just, I think, over half a year ago. He has more than 20 years of experience leading teams and driving revenue for Fortune 500 companies and private equity-backed technology companies. He spent 10 years at IBM as a group general manager, where he led the end-to-end delivery of enterprise products and platforms for a diverse portfolio of global customers. In addition, he has held leadership roles at CA Technologies and Broadcom and worked as a special advisor to digital transformation company Digital.ai, where he helped the senior leadership team devise the product and platform vision and strategy. So it's going to be a super interesting opportunity to ask Ashok questions about sort of the future of KX, maybe the history of KX. But before we get to that, maybe you can tell us about your sort of abridged history of your path to being CEO of KX, and whether along the way you sort of stumbled into any of the array languages or sort of you discovered them upon arriving at KX. And yeah, be super interested to hear sort of the background that led you to where you are today.
Thanks, Connor. I think first of all, I would like to characterize myself as a lifelong learner. And I think in that context, you'll see that I kind of self-taught and started learning about different languages. And then it's kind of been a history which kind of got me where I am. But I think I started off my programming when I first started many years back in India, where we didn't have computers in those days. But one of my uncle gave me a sharp 1500 pocket computer to start coding more of a numerical analysis. So I tried to figure out, it wasn't BASIC at that time, but then I tried to program Newton-Raphson based, how do you solve differential equations, right? So I started off with that, and then it was the first discovery of using subscripted variables, which was the first array. When I first discovered that is where I thought, wow, instead of having separate variable for each thing, I can actually create something as a subscript, and that was my, it started off that way. And then over the years, I worked, Fortran. I did, I'm a chemical engineer by background. So you kind of I look at engineering as more about solving problems mathematically. It's more like applied math, right? You're trying to represent physical systems in mathematically, and then you try to solve it. And that's really where I kind of did most of my learning in that context of not just programming, because I think it's really about applying math and how do you represent math in a way where it's the best way of representing physical systems. And then I learned Fortran, and then I moved to US and did a lot of things. I've worked in creating the first .NET for Visual Studio when Microsoft was introducing .NET languages, the common language runtime. So I was the product manager for this J# product, which was the Java for .NET. So I ended up learning and creating type system. And then I ended up working with the rational software around UML and object-oriented systems programming, where we are trying to abstract things. Instead of programming at the language level, you kind of move up the chain. So I worked with Grady Booch and Jim Rumba, and you were the three amigos to kind of, for a while, it was all about object-oriented programming, and you would not program at the lowest level, but maybe everybody is going to program at the objects. But that, the model-driven development didn't pan out like the way we thought over the years. But then I also worked in the mainframe when I was in IBM. Rational got acquired by IBM, and so I ended up knowing quite a bit about COBOL, and this is one of the best systems ever designed in terms of the systems. It was started in 1964, but then I trying to learn about how the COBOL works, and then I think recently, as I said, a lifelong learner. I went back to school and Georgia Tech and actually did a lot of things around AI, ML, and that I got into JavaScript and Python. And I think the one with KX is really where I kind of was trying to really understand the power of array programming, because the whole notion of how you can represent mathematically things like the speed of thought. I heard, a lot of times I've listened to the ArrayCast podcasts, which are brilliant. I mean, many of the people like Nick, he's the guy, he and I have talked about why is array-based programming so useful, because I think he kind of translated that to coding at the speed of thought to getting to insights at speed of thought, right? That comes down to, I think, the mathematical representation of things where people can represent their thoughts in mathematics. And the last thing, I think one of the things I found with Q, and when I talk to customers, it's even though it's terse, people talk about being terse and how you represent, but it represents things so well, whereas all the other programming languages, the best programmer in one of the companies where has done the most work in array-based programming, it was surprisingly a visually impaired person who couldn't read or see, and she was doing everything better than anybody else. That's because it's so expressive in terms of what it can represent. So it's where it kind of opened my eyes into what it could do and what are the use cases, which I can talk some of it in terms of what type of things we are seeing with customers and where we are going. So that's really my kind of background in terms of where I am. But I'm a technical, people call me as a first technical CEO for KX. So that means it's just that more I understand technology, and I'm still trying to solve customers' problems. But it so happens, I think sometimes people will find that if you can understand them, because it's not just technology, but how does it solve problems? So I take it as a compliment, not necessarily like I'm a geek CEO for the first time.
It's actually interesting. When you just said that, the first technical CEO, it immediately made me think of, there was I won't say which company I was at, but a company I've worked at, there was one time they brought in some consultant from, I think it was, I don't know, one of the big consulting, Accenture, something like that. And I thought it was going to be a very like consulty, buzzwordy kind of thing. Like that was just my bias whenever I see that. And then very quickly, the first thing they said was, I'll tell you about my history. I started off, writing small talk at Xerox PARC or something. And I was like, wait, what? Small talk at Xerox PARC? Like, that is definitely not what I expected. And so it's something similar, because you just, rattled through, all the way back to, Fortran and COBOL and J#. Correct me if I'm wrong. Is that was the name before C#, and then was it Oracle or some company was going to sue, or was that a different J something?
Yeah, so no. It is actually J++ was Microsoft version of Java. Sun was suing Microsoft at those days. That was before the .com.
Okay.
And when they introduced .NET, Sun wouldn't allow them to launch it. So Rational, as a separate company, developed this, and that's why I was able to do that and work on. So J# was really the Java for .NET, and it was the J++ to J#. So C# still exists, but it's the C# looks like Java, but it's like, it has its own constructs. But whereas J# was Java syntax, but it leveraged the common language runtime from .NET.
Okay, interesting. So J++ was the one I was thinking of, and J# was
Yes. Visual. I think it was all this Visual J++, which was very popular, but I think it fragmented the whole notion of you write once, run anywhere of Java, and it had extensions which only would work very well on Microsoft. But if you write something in J++, it wouldn't run anywhere else. So that's where Sun, those days, didn't like. They thought that they broke the value prop of Java, and I think Microsoft ended up trying to create this J# to kind of do the same thing, make it easy for people to use, but it looked like Java, but it was really .NET language.
Interesting. Yeah, C#, that whole space is something I wish I knew more about. Like I was looking at rankings of languages, and C# actually ranked higher than C++, which I was a bit surprised by. And I looked just at the latest releases, and it's all the way up to like C# 11 at this point. And there's been so much evolution. I think like C# 3 or 5 was the one that introduced LINQ, which has become like a really popular paradigm within C# programming. But anyways, there's been like 6 or 8 releases.
That's the LNQ.
Yeah,
LINQ.
LINQ.
Right?
It's like a sort of
composable
algorithms, and it's linked to sort of, what do you call it, SQL as well.
It's a little bit array-like.
Yeah, it's kind of.
It's more of an SQL thing.
But anyways, the point being is that like I hadn't realized that there had been so many releases, and apparently the functionality that's been added to it, it's completely changed from what it was back, however many years ago C# 3 was. Anyways, back to KX and array languages. I'm not sure. Should we pause if there's questions from anyone else first before we ask maybe?
Well, I'd like to ask then, did you bump into any of array languages before coming to KX?
No, I think to me, the starting with what I found with more from, I knew array languages in the sense more like solving the problem. If you think about, I actually thought, when you look at your spreadsheets, right? I started with VisiCalc, which was my first one, which after I did, it was trying to solve the type of things what we're trying to do in arrays, but using a spreadsheet. But I don't think recently only I've found that Excel or others have introduced some dynamic array, but it's very hard to kind of do that in any of these spreadsheets, right? So I wasn't really. I think I learned more about it in the context of before I joined KX, I did a lot of research, and that's when I kind of learned not only Q but went back to looking at K. And one of the things I found is, like, for example, when I did Newton-Raphson, you do a lot of loops and you try to guess, you have to start with the initial estimate to figure out what the tangent or the slope is when you try to solve a differential equation. But there's a lot of loops and you get caught with it. And I think we don't know when it doesn't converge to a root and it takes forever. And with this, I saw, some example I kind of wrote myself was to write one line Newton-Raphson. I never imagined you could write something something like a Q, you can write in one line, you can solve the whole Newton-Raphson, which is where I kind of stumbled about the power of it, right? So, I had not really worked or run into it, but I did have conceptually, I kind of understood this thing, and then things like implicit parallelization, things like that, which I find what array programming brings. I think I was kind of fascinated with that, but I had not used any language or I'm not familiar with any other languages.
You mentioned UML and working with Grady Booch and that and taking the programming up a level. Do you see a parallel to how Q is used that way, that it's array programming but brought up that you're thinking sort of on a higher level, or do you look at it that way? Yeah, no,
I think one of the things what we are trying to do as a company is the power of, first of all, I think Q is, less terse than K, for example. Like K it's even, just say a dot or something like that means something, and it goes beyond that. Q becomes a little more this. It's still terse. And so the people who know, like Nick, he's written multiple books, but it's the power of that. How do you bring that value of helping people to code at the speed of thought or get insights? It's not very easy for, except for a small population in this world. So what we are trying to do is we kind of democratize it and to get more people to do that, so get to the same thing. So one of the bigger areas, what we have been doing is to help people to use Python, and you wrap Q and underneath the K. So you can actually use just Python because there's more than several million people using it. And so you can get the capabilities and the power of Q and the array-based programming just using Python. That is where one area we are focused on. And the other one, which is recently, it's interesting, the whole LLM and the chat GPT, right? We just had some things which I'd asked the internal teams to go and do it. And they did that. They took some of the Q best ways of doing some of this and, use chat GPT to help people to kind of, okay, if this is what I want to do, and here is the Q code, how it would represent. If I want to do a matrix multiplication, how do I do that? And instead of knowing Q, you can actually chat GPT generates that, right? And so we are thinking more that higher level means that maybe, there is a play for generative AI to help people to do that and train and learn versus we actually doing, there's one way of doing it in Python, but still, if you want to get the full power of Q, you'll have to use Q because it has certain things where only Q, it's the way you write, it's thinking differently, right? The way I thought people who come from object-oriented programming, going back to my example, they have a hard time understanding learning Q because it's thinking differently. You're thinking mathematically. You're thinking right to left because everything is terse because there's a reason for it, the way Arthur designed it. And it's not easy to replicate that in a Python because it's designed for more people to understand, but it's not expressive in a very short way to do it without consuming a lot of power. Memory. It uses things which are joins and things like that in memory. So I think we can abstract to some extent, but in order to truly get the power, I think people will end up having to, still continue to program in Q for some reason, or K in some cases. But it's more, I think about it as a spectrum, and it's like, you want to democratize it. It's like a photography, right? When people had all this, professional photographers, only they understand the best, where to get photographs and the depth and all the things. But, over a period of time, like everybody uses iPhone right now to take the pictures, but you still have the high-end cameras and the photographers and people who do for take National Geographic. Only they understand that, and you can't suddenly use iPhone to do what they do right. So yes, it looks on paper because your eye only can recognize so many pixels, but so that's the way I think about it is more, can we abstract it to a point where we also you don't want to take away the power. And that I think is the challenge we have, I think, X, where we went too much trying to democratize it, but we kind of lost focus on the power users and people who thought, hey, what are you doing around Q? What are you doing on KDB Plus? So I kind of brought it back to even we didn't even allow people download. So we have, KDB Plus available 64-bit. We are investing in 128-bit or 256-bit. We are doing a lot of things for the power users, but also helping more people to get to it through Python. And now with Microsoft is working with Microsoft, we're releasing a Visual Studio Code for Q and SQL and PyKX, which will hopefully make it much more easier for people to program, get the value. And that I think is huge. I think our customers are very excited about it because you're abstracting in terms of auto completion to how do I debug, how do I do all this stuff. And I think part of that challenge we have today is complaining people don't understand the error messages and it says a type error. And it's the famous type error where you're doing something and you don't know what it is, right? So anyway, hopefully that answers the question, but it's sort of like you can do object-oriented, but it's not expressive enough. That's what happened with UML, right? People ended up programming and doing reverse engineering to get to the model versus starting with the model and generating the code.
It does, and I love the photography analogy because I think that's so apt, and especially when you think about people using iPhones to take pictures. I've heard so many people saying that they'll take an iPhone with them to take pictures because it takes really good pictures, but if they're really good photographers, they've also got a big camera in their back because they know that there's things that the big camera can do that the iPhone can't. Yeah. But most of the time for a snap, the iPhone's perfect.
Yeah. Wait, so just to be clear, in this analogy, the iPhone camera is Python and the heavy-duty fancy camera is Q?
Yes.
Okay. just so I understood which language is what.
Because Q is a lot smaller on your disk than Python. Let's be clear.
Yeah.
No, which is also true, right? It's kind of not intuitive because I think it's that. Oh yeah, I think about that's why you use so much little. You can you can do a lot more power. With it's just that in iPhone, when we say Python or others, it's just a lot more people can do it, but it does take more power, more things to do it. Even the energy consumption, we find that with the Q, it's the smallest footprint thing out there, right? It's less than 1 MB and it's 840 lines of code. People get astonished in terms of what it can do in terms of the edge computing. And there is a statistic I saw Gartner put out in 3 years. The data analytics and other things, what people are trying to do will take more power, consume more power, all the data centers than all of what humankind consumes today in power. So if you think about if you can do with array and all the things if you can save 10% of that, how much more sustainable this world will be, right? So to me, I think it's like we kind of go too much on ease of use and getting more people to do things, but it also creates a lot of inefficient systems and coding and others where where I started off as software engineering. This is one field where people confuse programming for engineering. It's not really engineering. It's just because if you can type, you are not a writer, right? You need to know how to write. And just because something makes it easy for you to type, it doesn't make you a writer. So I think it's the same thing with programming. I think to me, you have to engineer things and you need to think what's the most efficient. And I think array programming, I find it forces you to think efficient. It thinks about what's really required versus just making it easy to write a lot of code. And then, yes, you can debug it, but it just makes it hard for people to maintain and over a long period of time. I think that's a balance.
Stephen?
Ashok, you were speaking a few minutes ago about using Q to get the full power of KDB. And I'd like, if I may, to tease out of that two distinct meanings. One is that there are certain things that KDB will do that you can only really get it to do efficiently in Q. So that while we democratize the access to it and provide access through Python and so forth, if you want to get something running really fast and hot, certain things, certain kinds of queries, you're going to want to drop them into Q. That's one aspect of the power. The other is the expressivity that you were talking about and the way you were just saying that it disciplines your thinking. And I'm wondering if you see a future for Q as a general purpose programming language, besides the role it's already established for itself or getting into big time series databases.
Yeah, I think the first one, I think the Q, there are lots of things it was designed to truly help somebody to code. Like when we talk about coding at the speed of thought is when I talk to customers and what they say is that they can start working on something where some things take 6 months to a year to write something in other languages, and Q allows them to get to it in a way where it's not just a language because it has underneath, like if you want to compare things what happened between two periods, just like 2 lines of code which I can write to kind of say, okay, tell me what happened this year versus last year, or if I'm trying to figure out what the next COVID vaccine is, I want to compare different populations during different time periods. Just trying to do that, anything with like a Python or whatever, and it takes a lot of effort for somebody to define that paradigm of just like think about like a TO, right? If I'm doing something in real time and I want to go and compare, all these things that we define, like these periods and comparing something and how do I iterate through it and make it up. Whereas with Q, it allows you to just express it. I've got this whole thing happened last year. I can just get to that as a vector. I can just get to that, compare with another one without having to go and look at all of entire population of data, which is a waste of time and effort, for example, right? Most people, when they write a SQL query, it takes the entire data to kind of make sense of something. I can't just pick this table and this period. Those are all first-class citizens in Q. And that, I think, is the power, it's making it, not only it stirs, but there's a reason for it because you are making everything first-class citizens to compare. Or if I do joins, like when I think, you heard about as of joins and others think as of this time, what happens? Those are constructs which are not available in any other language right now. And so what happens is we are bringing some of it to SQL and Python. We actually are making it easy for people to, as of join as a one which kind of brings two things together using Python, but it's still underneath it's calling queue. But I believe that for more like the professional photographers equivalent, they can take advantage of the queue power better than, somebody has got. Python is still a wrapper around queue, but it's not, easy to somebody to run this. And because I think there are lots of libraries and others which people have built up in Python to run in the Python process. That's a different than what we are doing is to run in a KDB and queue process. So there we are really wrapping things in Python, but really it's running in queue process, right? So that's where there's certain things you can do directly in queue is what I would say the efficiency and the power comes into picture. The things where the other example is I would say, we do a lot of things in memory and queue it's in memory mapping. So whether you're storing something on storage or in memory, it doesn't matter. It can use that as one space. And, if you are processing a stock ticker symbol, like if you are looking at a Microsoft and it's coming through, most people store it as it comes through. And with all the other data, it's all over the place in the memory. Whereas with Q, you're able to naturally, because of time and the way it organizes things, it's already sorted. It's all in one column. It's in one single memory space. So when you try to ask a question, it can answer in the context of speed of thought because it's a lot easier, right? You can try something, and this is what customers tell us. I think what they say is the power of Q is it's limited by your imagination of the question you can ask. Whereas everything else, you need to know what your question is first. Then you program it. Then you figure out whether it answers. So that's the difference. I mean, that's where I think the Q is to think about it as it truly allows you to ask a question because most of the time people don't know what the questions are until they see something where they get insight and then you kind of reframe the question. But most of the time, if the data is aggregated in a way where you are already not collected the data stored in that way, the queries, you can't answer the question. Whereas Q is able to go back and because it doesn't throw away any data, it's all in memory, you're able to answer the question without worrying about did I actually collect and store and do this in a way where the programming language can answer. And I think the second part of their question, I forgot what you said.
Do you see a future for Q as a general purpose programming language?
I think it's a good question. I don't know the answer in terms of, I think there is the notion of what I just talked about, making it easier for like something like ChatGPT and others. If you actually provide the framework to people to use it, I think I've found that Q, as good as it is, there are some programming, the people who really understand it, because it doesn't come with any bound, like frameworks and things where, people are used to like abstractions, right? If you have a class, you have all these things which are all available for people to kind of programming any other language. You don't have that. The discipline comes from people building their own ways of rules around it to program. That to me is one of the challenge with becoming a general purpose programming language today is it starts everything from scratch almost, right? You need to know natively, you need to build everything. It doesn't have that built-in capabilities like, all the other languages provide. So that I think is where we have to think about how do we make that easier, right? Is there a set of frameworks and guidelines and guardrails for people to not go and create really bad code? Because there are people I've seen where there's people who understand the power of Q can create really efficient things, it can take advantage of it. But then there are people who come out of Java and other languages, they try to program it the way they know it. and it ends up being in the wrong place. And where I see a lot of problems with the customers are the second class of problems where people who come from mathematics, physics background do a much better job of using Q than people who come out of traditional computer science and language background, if that makes sense.
Yeah. So we need, it sounds like we need a better collection of libraries and example code and so forth.
Yeah, I think that's my thing is also, I mean, you'll have to, it's a different way of thinking about the problem, mathematically how to solve something versus if I just want to apply programming like the way, let me give me equivalent of what this I do in Java or JavaScript or Python. What's the equivalent of that in Q? I think that's the wrong way to go about it versus thinking about it, solving the problem in a way it's different, right? It's mathematically you're solving something, thinking linear algebra, thinking matrix, thinking, how do I represent a problem? Those are the people who are successful. And that's how do we make them easier? What's the starting point for them? What is the foundational blocks is where I think it could become more general purpose.
Have you had, because you've mentioned ChatGPT a couple of times, and I think you even said that you had some folks try and use it to program with Q. Did you actually do that exercise and find success? Because I know that several people have DM'd me screenshot or tweeted screenshots of me of attempting to get ChatGPT to write some simple thing in a series of languages. First do it in C++, then modernize it, then switch it to Rust, then do the same thing in APL. And everything was correct. But when it got to the APL, it did something that if you knew nothing about APL, it was very confident about that it had executed and written the code, but it was doing completely something that wouldn't even compile or I guess run. So did you find, one, did you actually have people try that with Q? And two, if so, did you find success with that? Because I think that's niche languages. It's ChatGPT, I think it seems to struggle. So I'm interested if you found success.
Yeah, no, I think it's a good question. I mean, we are at early stages. What I found is, I think if we look at the models, what we can train them on, right? I mean, from Q, it's just, it becomes based on what we are able to. ChatGPT on its own probably obviously doesn't know Q, but what we have been able to do is to kind of train based on some of the models and the things what we can feed. And so based on that, I think it is able to do things if I say, hey, do this matrix multiplication or tell me a trading, tell me what is my anomaly or, it's kind of finding using what's the equivalent code of Q to solve the problem, right? In terms of the market data is coming in real time and I want to tell you if this particular is somebody spoofing you or whatever. So depends on what we kind of train and what we provided. I think we are starting to see that, but I just feel we have to do KX and the community. I want to be able to kind of create that large language model for APL or Q. I mean, that's potentially where I think we can do. And I think that's it's early stages at this point, but I see that I think, is it Stephen, you're sharing something and it has done some, we are doing some things like that, what he is showing here, where it can give what's the equivalent of writing something in Q where people don't have to know it.
Is this something you did, Stephen? Is it Stephen this sharing? I can't tell. It is Stephen.
It's one of our colleagues, Rian, and this is the third of the screenshots that Rian sent me, and in the first two, ChatGPT had answered some questions fairly sensibly with some simple stuff was correct. Then in the third, it was asked to write a function to list files in a folder and sort by size. And when you glance at it, you think, oh, wow, that's pretty good. And then when you look at it, you see, hang on, that's not actually cute.
I was going to say, I don't see, it kind of looks Q-ish, but yeah, I don't see a sort function anywhere.
I think what you've got here is that chatbots are really good mimics, and the mimicry can spill over into bluffing.
Yeah.
So to get it to guide people, we've got an interesting journey.
It's interesting though what Ashok, what you were saying though is that you kind of, to me, it sounds like you're describing like a prompt engineering system where basically it's a tool that you can build that is, chat GPT flavored, where you basically just ask it things and then somehow you train the model behind it to basically use Q and KDB plus to do like, very fast querying of time series databases to whether it's financial applications, which is typically what right now what Q is used for in KDB plus. That could be like a very interesting, because you could imagine people sitting at like a Wall Street trader desk that are not technical in nature, but that want to throw a bunch of queries at it, and the idea that you could just speak to some Echo device currently today does not exist, but you can imagine combining these two technologies. You would need to do a little bit of work. You'd need to feed the GPT model. You need to train it on, a corpus of Q queries and stuff. But you could imagine that, like in the near future, that would be something that you could hand some text to, internally Q to like answer of querying, whether it's time series data on Wall Street or something else. Like that could definitely be a thing. And it's very interesting to think, like, what would you do with that kind of technology? I'm sure there's applications way outside of Wall Street that would be useful for.
No, I agree. I mean, that I think is exactly, we looking at more when we talk about democratizing, it's really when people, what they do with data and how they make decisions. And a lot of times people try to say, I need a data scientist or whoever is going to do that. But generally it's a line of business person, it's a trader, it's a, operations person is running manufacturing. They're trying to figure out efficiency or what they can state the problem and what the question is, but then, translating that, it takes an army of people, and sometimes it gets lost in translation by the time that you get the answer, right? So I think to me, there are some things which are, I would say to answer Q, and I think that's part of the perception KDB is used in capital markets quite a bit, but then what I found is we have a lot of people using in the last year or two on other use cases, right? We have capabilities in clinical trials, right? The things what I find is more of a pattern is how do I look at the anomalies to observability is a big area where we look at systems and being able to make sense of data. So there's a customer of ours who does clinical trials for 92% of the companies in the world who do clinical trials. And they were involved in kind of finding the vaccines for COVID, right? That used to take 6 years to find something, and they compressed the time to 1 year. And now they're trying to compress it to 30 days, right? With the number of variants and other things going on. So they're actually they used to use MATLAB, and now they're using Q with KDB to look at massive amounts of data, but also compare things, which countries are efficacy perspective. And now they're increasingly looking at how do I look at healthcare data as a service to kind of start looking at how do I find the right profile of people who could, that's one of the problems they have, in the world, so many people and billions of people. So I think that's something which we find that medical devices to people like aerospace and defense, like we've got planes flying around and trying to find in enemy territory which ones are missiles versus public population. Like if you look at Ukraine and what Russia is doing, to me, those are a lot of use cases. What we're finding is they're applying this because these are massive vector-hungry data use cases. If you're trying to solve the problem of genetics, biotech, right? These are things which people run queries. It takes days and months to sometimes. And if you apply this sort of a technology in an array-based and vector-based thing, you're able to compress the time to very little where we can get answers, or at least you can try different things. So that, I think, is what I'm finding is that we are seeing a lot of the use cases around manufacturing, semiconductors, where the fabs, right? We have a shortage of chips right now, and every time you find a fault in a chip, you have to throw out the whole thing, and that's millions of dollars of cost, and then it creates supply chain problems. So I think there's lots of these things like in telco and by the experience of customer, and you're finding the time to make decisions is compressing. And then if you want to even take the Wall Street, coming back to capital markets, we used to settle trades in 6 days. It went to 2 days. Now there is a requirement in US and Canada by next year, you have to settle trades in what we call T+1, from T+2 to T+1. So how do you settle things? It has to, not only buying or selling things, you have to transfer the shares, you have to make sure that verify everything, who bought, who sold, and you don't even have a full business day to settle that, right? So that compresses time. And so think about the amount of volumes of data you have to process, what kind of analytics you have to apply. You're looking at risks, you're looking at foreign exchange. It implies petabytes to zettabytes of data you have to process. And so to me, that's, I think, is where it's going towards, right? I mean, we really are compressing time, and now you have to think about all areas where that happens, whether it's finding vaccines or, you're trying to find in split second whether I'm targeting a enemy system or trying to do that for, medical devices, right? So that, I think, is, I just want to clarify that, there's more and more use cases what we're finding beyond the capital markets.
A use case that I'm aware of is Formula One racing, which people may not have realized that a lot of KX has been involved with many of the teams. I think you're still involved. I'm not sure going forward, but last year was it Alpine and Williams were the two that you were working with?
Yes, I think Alpine, is a good use case. I think what we found in that one is the actual use case is 60,000 different sensors coming in, even during a race. They collect all this data and then they have to process and try to determine how to optimize for the race, what I need to be looking at. But also, they're also using that to design the next generation of cars. So there's two elements to it, right? How do I look at all the sensors? It's really a IoT or an edge type use case. And, now that's what I think is going from a time series data to machine data, sensor data, and now you're getting more and more data. And so Alpine, and we still work with them. They are now increasing the amount of data, but they're also using cloud because that's becoming the way to aggregate data. And we're working with some others in that context also, right? I think that's the very interesting that I look at it as not just solving a Formula One racing problem as much as the telematics, how do you bring all this data and being able to make sense. And I think using array-based approach to solve that is how we can get to very fast insights. And then, you think about how much time they have to react between the laps. And now you can also apply that learnings to the actual design of the cars and self-driving systems.
And people may see Alpine as not one of the top teams now. They're sort of the second tier. But one of the things I'd point out to them was the year before, Red Bull, who's a very design-driven team, won the World Championship. They were using KX, which my dad was involved with Formula One, and he often said, if you want to see how a team's successful, look what they were doing the year before they won.
Yes.
Because that will tell you what the right thing to do is. And KX, I noticed this because I saw KX as one of the sponsors and one of the emblems on the Red Bull cars, and they weren't the next year, but that was the year that Red Bull won and continued to win. So I think it sets that foundation for those kind of things. They got the step up on a number of people, and now other teams are trying to use it as well. I'm just wondering whether there is, when I think about areas like that you said there's Internet of Things and then there's time series, I can see so many things like in terms of energy, managing, balancing electrical grids, those kind of things, more people coming online with their own solar power and trying to figure out when you're going to feed a system or take from a system. I would think that would be an area that KX is probably looking at as well.
No, absolutely. I think, the whole notion of smart grids are big, right? Everywhere we're starting to use smart meters and smart grids. So we actually do that for the whole country of Finland, and we have got several countries now. Poland is the next one, which we are starting to do, and especially they're so worried about the infrastructure in kind of, so we have this, what we call a Fin grid. So we manage the entire Finland grid, and it's all powered by KDB and Q, and it processes so much information, but also improves the efficiency of the whole energy system. And then you also are now replicating that across different countries, right? So yeah, that I think is something which we continue to look at, because to me, the amount of power is really needed, the efficiency, we waste a lot of power. And so trying to, apply the efficiency, and we talk about sustainable. I know Stephen has done a bunch of things around it to show how little power we can consume. And that's one aspect, but then just looking at all this data and being able to optimize it for entire countries to save power. And then, countries like India, for example, right? I mean, there is literally, the country is growing so rapidly, and they skipped the whole infrastructure problem by moving to wireless. And now they need so much power because India is the number one country for AI right now. And that's what Satya Nadella was in India a couple of weeks ago, talking about how they're putting 4 data centers in India, Azure, and it's become the number one country to apply AI. So all it means is you're consuming more power, and think about where the energy comes from. And they're dependent on imports and oil and other things. So there is definitely, that's a big thing what we can do, and not just from as a KX as a company or product, but more from just the humanity and what we can do to address the bigger problems, right? The energy and some of the things what we can do around saving lives, finding it's continued to COVID, and it's new variations, and it's rapidly evolving. It's dynamically changing. So it's just like, how do the people talk about predicting the landing of a hurricane? Think about that problem. If you want to predict the landfall of hurricane, the type of things what you need to look at dynamically, all the things around this wind speed and everything else happening dynamically to where it's going to land, what happens to systems. You bring all of it combination, and that's truly the type of system when you try to predict the next COVID vaccine, or the type of things we can do in energy. So that's the type of problems I think we are involved in and continue to solve, because again, it's all powered by the vector and array type things.
I'll be, I guess, remiss if I don't ask. You've mentioned now like a bunch of different, I don't know if you want to call them success stories, but just capital markets, hedge funds, vaccine research. I had no idea about like the Fin grid and entering Poland. As the CEO, I guess you're one of the best people to ask. Is there sort of like a huge success story other than the ones that you've mentioned that like people wouldn't necessarily know about that KDB Plus is being used for, that you're able to share? Obviously, you're not able to talk about all the people that use your software. They've got confidential stuff, but like just the Fin grid one, I was like, oh, like you're powering, something for a whole country. It's like a pretty massive thing to be able to say about a technology that you're building that I had no idea about. Like, are there other things like that?
Yeah, no, absolutely. I think, one area where we are doing a lot is around semiconductors, right? So right now, the whole world, everybody's investing in semiconductors. And we have a company which basically powers pretty much all fabs in the world. For example, it's used KDB and Q to support fault detection in manufacturing in all the fabs, right? These are disconnected wire gap systems. And as I said, like, it's kind of finding those faults and being able to predict things before they fail. And these are massive systems. I mean, these are fabs are $1 billion or multiple $1 billion things worldwide. There's about 160 of these where we power and we find faults. So that's one area. Semiconductors, manufacturing, when you look at people who manufacture medical devices, and like, for example, I'll give you an example of one of the largest manufacturer of stents, which goes into human hearts. And that is such a big safety critical system, right? I mean, if you put a bad stent in somebody, finding problems in stents, and how do you make sure that, and that company is now not only doing it in one factory, they're doing it across all the medical device, across 70 factories worldwide. So that to me is a big thing for us. I mean, in medical devices, clinical trials, but generally life sciences, I think, is an area where we are seeing increasingly people are trying to solve the problem of the biotech genetics. I think we have several people who are using this for research in life sciences. So finding the next big drug in pharmaceutical, I think that's a big, and these are names we're hoping to announce. We just announced this morning, there's a press release around enterprise web, which is in the telco space, which is basically between Intel, Red Hat, us, and a couple of these companies, where think about what's happening in the data, which is the 5G is creating massive amounts of data and networks. And how do you actually process all this in the networks and make sure that you can continue to provide the experience? It's huge. I mean, that's where all the telcos are investing in the networks. And if a network fails, world stops. Think about what happens during COVID. If you didn't have access to the network, I remember when we lost power in my house in Texas, and we were out without power. My kids were running around. They were saying they still had network, and as long as there's a network, they're saying they are connected. They're happy. They didn't have power. They didn't have water, but they're saying, "I've got network." So I think we are looking at this as the big 5G and telco is a big thing for us. So those are. I mean, I think some of them. I mean, I can name the partners we are working with. Microsoft is a huge partner with us. We are working with them on many manufacturing things, which is what on Azure, they use us as a strategic capability, right? We used to be not just on-prem customers. So Microsoft is using us not only in the financial services, now we are working with them across healthcare, what they call industry clouds, pretty much in all the clouds in the industry perspective. That's where everybody is going now, right? The industry clouds means you're solving specific problems. So anything with this shape of the problem, time series, machine data, high speed, analytics in real time, Microsoft is using us. This is the second most valuable company in the world, the hyperscaler. They're using KDB and KX insights for that. So I would say you'll see the names, the top 40 companies, the biggest banks in the world are using our stuff right now. And that tells something, but now we are actually saying that the top 10 brands, whether in different industries, are working with us right now through Microsoft, as well as some of what we are doing with AWS. So I think that's, I'm hoping to share more as we go through. But, the big thing we're doing is we are going to announce the new KDB Insights at the end of the month, which will have Microsoft Visual Studio Code. We'll have more support. We also want to open source what we call a PyKX, so that we haven't announced it publicly, but that's something which I want to do to open it up for more people to contribute and basically, provide that, enable the community to do more use cases versus be dependent on just us, right? We want enable that. We want to open it up, right? That's something which we are massive, investments we're making, and we are also big partners like Microsoft teaming with us to do that.
Or go ahead, Bob.
You were mentioning earlier that top-end Q programmer is developing their own frameworks because they can tune things to exactly what they want. And to me, that's really impressive. But and to hear you just say about opening it up, I think that does create a challenge. Being able to configure things so precisely does create a challenge to being able to open things up across industries, because as soon as you can be so insular, you tend not to share as much because you've worked on that power. But it does sound to me like if you're opening things up by making it wider across companies, you may get the benefit of having a number of different groups work towards a common goal, which I think obviously the business plan for KX is working for KX really well, but I do think it might have got in the way of that opening up process. Do you see that as well?
No, absolutely. But I think, as a company, what I find is we, as a part of the broader FD, we also were in the consulting business. And so to some extent, I think we kind of looked at everything what somebody else did with Q was competition to us. Instead of, and it doesn't matter who created frameworks or what they did to enhance. That, I think, is a fundamental shift, what my perspective, which is we really want to be a software company to partner with customers and not be doing everything ourselves. And they don't have to come to us. And, even for, like, we had cryptic error messages because, people would call us and get support from us. And that's insane, right? So we are trying to make it easy for the communities and, a lot of SIs and others, which you'll see some increasingly, we are announcing some partnerships where we are not in the services business, right? We don't want to be making money off services for KX. It's as much of, we want to be the engine to power these sort of applications people are building to solve the biggest problems. And the more people can create these frameworks, more open source we can do, more sharing. Our customers are asking for us. They want to share. So we want to enable that. How do we enable these sort of frameworks, the best practices and others where people can share and use time to value to get to that? At the end of the day, I always think about getting to the race is our problem. But once we get to the race, we can help people. So let's not make it hard for people to get to the race. And we want to be the engine to power that versus trying to build everything ourselves.
And I guess the thing is, you've got a big, powerful, fast engine. It's also expensive, but that actually puts it at the scale of these larger country-sized energy grids and things like that, where those groups can actually afford that, to be able to use that engine. It's not something you're looking at as much for, single users or anything, although I think you have created a market for people who might want to learn to program in Q by opening up the personal, the licenses that you can learn to use the equipment, but you probably will never be able to afford the engine on your own.
Yeah, no, I think, that's the thing what we are trying to do is, first of all, I think we have this KDB and Q now available for personal use for free. They can use it. The license, anybody can go to kx.com and get that, right? So I found we have hundreds of downloads from different companies, but also the top schools. The most people who are downloading from Stanford, from Princeton, from Cambridge and Oxford, which is great to see. I mean, we have got lots of PhD and quants and others are using that, so which is great. We also are going to have a trial of the entire capability end of the month where people can use it. It's more once they deploy to production and they start using in big companies is where we want to monetize, but not, let people build for a lot of different things themselves. They can use it. So I think the idea would be to more focus on, where we want to move up the higher the stack, but not prevent, from people. And that pricing, licensing in the context of the cloud is much more of a consumption based and what people can adopt, and they can start free and then they can get to higher value. And that's really the approach we're taking. And you'll see, more and more of that.
One of the things you quickly mentioned in the stuff that's going to be announced with the KX Insights release, what you said, Visual Studio Code, does that mean there's going to be some kind of extension that is usable with KDB Plus or Q or something like that?
Absolutely. So we have a partnership with Microsoft where we actually, if somebody can start with Visual Studio Code, there's a plugin, just like you have different language plugins, right, from Visual Studio, from Java to J. So you have a Q plugin to which kind of provides debugging to all the documentation, and there is a PyKX or a Python interface to KDB and Q. All that is built in, and they can do everything without having a separate Python environment, for example, and debugging, autocomplete to how they can debug, how can they troubleshoot. They can do it all with just Visual Studio Code without getting anything from us. And it's going to also use the standard things like Anaconda and pip install. It used to be everything had to be, KDB or KX versions of these things, and you had to know about our stuff. So yeah, so everything what we're doing with Visual Studio Code is, if you know Visual Studio Code, if you're a developer, you're a data scientist or a data engineer, you can use it in the same environment and the workflows you're used to and develop Q code, or you can develop in Python or SQL and be able to generate real-time applications.
But you said without getting anything from you, but the actual language engine has to be there somewhere, no?
We are enabling that as part of, you can get the KDBQ, the free version of personal use. They can use it with this thing, and what we are packaging it up. So we'll have that somebody can.
So it's part of the extension.
Extension to download and use it. So that way you don't have to get multiple things and figure out to get a license and how to set up a queue on your machine and Python. So those are all the things we are on January 31st, we are going to be making available. And some of it was in alpha and beta. We want to make sure that, what we have real customers using already and giving us feedback before we put it out. And then obviously we'll expand on it.
That's super. We'll definitely make sure to, well, if we don't go and find a link and add it to this episode when it gets released, we'll add it to a future episode. But that is definitely, I think, something a lot of our listeners will be interested in, because currently, I'm not sure for all the languages, but definitely there are extensions. I know Optiva, I think, was the people that made like an APL one, but like you still, whether you're using VS Code or you're using the RIDE, you have to go and download an executable for the language, which it's not it takes 5 minutes to do, but having something that's all in one, and I guess it's pretty simple to do for Q, because the executable famously is quite small. So it doesn't actually increase the size of the extension by, a gigabyte or anything like that. So that's, we'll definitely make sure to add links when that gets announced, because
absolutely. No, we'll do that. I think basically our goal is to make it simple and with one line code, or, with a few things they can get to value. And it's, I think the other thing is there were some extensions by some other people that written some of it, but it wasn't robust. It wasn't having all that. So we have made all our debugging to our libraries, everything available working with Microsoft. So that's why it's much more robust, and it's going to be a first-class citizen within Visual Studio Code.
Interesting. Yeah, that definitely sounds. I'm sure, if not all of us, most of us will be checking that out once it drops to see. Yeah.
No, absolutely. And also, I would say that even the PyKX or Python, performance was a big focus for us. So if you do something in just Python, it is within 1% of the performance of what you get with Q. So I think it's been amazing with what our feedback from our customers is. We are talking about the largest banks and others who are using it, and we are getting a lot of positive feedback on just using Python, because a lot of times they may have one or two Q people in the company, and then they have 95% of the people who just know SQL and Python. So you can do ANSI SQL, and you can use Python without knowing as much on Q, but you can build really great systems.
And the overhead is 1%?
Yes, the Python, the performance is within 1% of what we get with Q.
That is, wow. I'm saying wow because on my former team at NVIDIA that I worked at, we had I guess it's slightly different. But anyways, we had a Python interface to a C++ and GPU accelerated library, and I think the overhead was, in some cases, like a factor of 10, which compared to previous, Python, it was 1,000 times faster when you run the C++. So dividing that by 10, it's still 100 times faster. Yeah. And people are still happy, but to only have a 1% overhead for the Python is quite impressive because.
No, absolutely. I mean, that's why I think customers tell us it runs about 100 times faster in terms of the performance, but it's like overall, 1/10 the infrastructure costs of anything else they need to use, because you spin up a lot less compute and storage and other things. So that's the other thing which I think Q does is the compression, right? It does because of the way it uses real time and others. We go, somebody's using S3, so 90% usage, it goes to 30%. But what's not intuitive, because the way we do it with some of the vector-based things, most of the time when people think I compress, I lose some fidelity of the data. We don't lose anything. And we kind of also, when you unzip, it's like a zip and unzip. People think it takes time to zip and then unzip. But it's actually, because the way we do it, the compressed data, we run as fast or better than uncompressed data. And that, I think, is very few people realize that. Right. I think when they actually run this is where they realize the power of it. And those are some of the things where, we want more people to experience. So through some other things, because it's not very clear until they actually see that. The wow, I can run a query. And so that's why I think we are now working with Snowflake to bring the power of Q to the data. We are working with them on making Q and Python to run in Snowpark, which is their Python implementation. And how can I get more value to the data? Because a lot of people are putting data into Snowflake, which as a partner, we are going to bring the power of Q and the vector-based processing to Snowflake, and we are going to do the same with the Databricks. So this is something where being an engine means that you want to bring the code and the power of Q to the data, not move the data to what you're doing in other languages and programming. So it's a completely different paradigm.
Yeah. I mean, those testimonials are amazing. They're the same team that I worked on. One of their clients was Capital One, and they had a testimonial from them that it was 100. I can't remember if it was, the two numbers were 100x and 30x. I can't remember which one was speed and which one was money, but one of them were applied to each. And I think it was like, 100x faster and 30 times cheaper or something like that, which like doesn't really make sense. But when you're running something, even the GPUs that they're running on them cost more. It's a fraction of the cost because it's so much faster. So the compute that you're paying for in the cloud is, it's pay less to go faster.
Yes, yeah.
Sounds like a scam, but it exists out there.
No, I think that's why there's a whole discipline of FinOps now, right? With the economy slowing down, everybody's focused on, when we talk about data, I mean, every query costs money, and more people, everybody want to be data driven. But the problem is you just are spinning up more things on cloud and running more queries. But if you don't think through it, you're going to bring massive volumes of data to answer a question. Like the query brings to 20 terabytes of data to answer something. A trader will want to do something and he wants to say everything. But you just need to bring what's necessary, right? That's the power. That's why I keep coming back to the array and vectors is you just focus on what's needed to answer the question instead of trying to bring the whole data across the wire and then the cloud. And that costs a lot of money. So the whole discipline of FinOps, where people are trying to figure out how to optimize my finance and being data driven is going to cost a lot of people a lot of money. But you need to optimize it to what questions you're trying to answer and don't need to move the data around to do this thing. And that's the paradox.
Yeah, it's important to get the, design of it correct. Otherwise, you end up spending a bunch of money that you don't need to spend. I realize that we've as always flown by the hour mark. Are there any sort of pressing questions that panelists have? We got one from Adam before we close up shop here, and
we have to ask the K question, don't we?
What's the K question?
Well, all this talk about Q. I mean, the company is even called KX, which I suppose it takes the name from the programming language K, but now you're in a position to maybe have it say, or at least an opinion, if you can say that. What's with the K programming language? Any future there at all? Or is it just going to be Q?
Yeah, so I think it's a good question. So one thing is, based on my understanding of what the name K came from, right? K stands actually keys to the kingdom. So we're actually giving people keys to the kingdom is what I understand the K from. But KX actually is true that it's supposed to have been, initially the company was formed where everything was named on the K versions of it. So that's why the X was, instead of changing the name of the company every time there's a new version of K, you end up saying KX. So it represents multiple versions of K. So,
really? I didn't know that. That's what the X and KX. Wait, is Steven shaking his head? No? You...
I heard a different story, but it doesn't mean that mine's true.
So, but I think, to your point, to me, I think it's more Q. I would love to meet with Arthur one day, and we want to look at how do we kind of look at what makes sense. And it's really, I always start with the customer problem and what we need to solve versus, so technology is there to solve some problems. So I think we have a really brilliant team in Charlie and others who are working on Q, and they've made it practical, and we're solving real world problems. So if there are things in K and the type of things what we need to bring forward to kind of enhance and go forward, that's why we're starting to see things like in machine learning and AI, they're doing matrix multiplication and trying to do some of the things what we want to do are not really efficient today. I think we can do things better. So I think I would like to take a look at it. I don't have an answer in terms of, what we would do with Q, K, and it's not necessarily Q is an answer as much as what's the problem we're trying to solve. And then how do we go about it? Is K, the new versions of K can give us some things to do differently. So that's the way I would think about. And, at some point, maybe in the future, we can look at that. And I don't have an answer beyond that at this point.
Any other pressing questions that we panelists want to ask while we have the CEO of KX here? Maybe stay tuned to next episode where we get Stephen Taylor at the top of the episode to tell his story of what the X and KX stands for.
I'm beginning to think we should have had Ashok on as part of the announcements.
Yes, this sounds like all announcements here.
Hopefully we don't fall under a non-disclosure agreement or something, and this will actually be on the air before. But I think we actually may have a scoop in a number of areas.
You heard it first here on the Arraycast.
Yeah, the number one array podcast in the world. All right. Well, if we don't have any other questions, I'll say thank you so much for coming on, Ashok. This was awesome to be able to ask you questions and to hear a little bit of thoughts from you personally and where the future of KX lies. And definitely thought-provoking to think about the possibility of a, prompt engineering system powered by, ChatGPT plus Q and K or KDB plus. And hopefully in the future. I mean, we've had on Geeta, who's the CEO of Dialog Limited, and I mean, J Software, I don't think officially has a CEO, but that would either be Eric or Rich, who we've both had on. And if there's a CEO of BQN, that's probably Marshall. So, I mean, we can say now that
not a company.
It's not. But if we were going to appoint one, so we basically now had all the CEOs on. So yeah, maybe in the future, whether that's a year out or a couple years out, we might like to have you back if you're willing and sort of see what's changed in the last 2 years and sort of, especially, if you get this chat GPT system up and running, or, probably it'll be called something different by then because this is the model now, but I'm sure there's going to be a GPT 4, 5, 6, 7, and they'll call them something different. But it would be awesome to have you back in the future to follow up on some of these future plans to see how it went.
Absolutely. Thanks for having me. And it's been an honor. I mean, I think I've listened to many of these Arraycasts, and I know that the audience is, I always feel it's a brilliant audience in terms of the type of things people have done and continue to do. So I would love to be back. And I do think that it's a pivotal, we are at an inflection point. And I think as a company and what we're doing with some of the hyperscalers, and hopefully, more customers will get benefit and the ecosystem.
Yeah, awesome. And we will, as always, we'll leave all links in the show notes for folks that want to check out. And be sure all the things that are getting announced in Jan 31, we'll try and come back and link them here. But if not, we'll link them in the future episode. And over to Bob for the closing. Contact us at
the usual contact at arraycast.com if you want to get in touch with us. And we've had lots of good suggestions. And we look forward to interacting with our community. It's always a lot of fun. And those emails get sent off to the Slack channel that we're all part of. So they get discussed there, and sometimes you get answers back. But know that they're read and they're appreciated. And also appreciation out to Sanjay and Igor, who help out with the transcripts, which are also available on the site. So if you, I know there are some people who, as much as they love, our voices are wonderful voices to listen to. I know there are some people who actually just go through the transcripts and read them, which is fine. Any way that you would like to consume us, we're happy to be part of. And I think that's all I've got to say.
Yeah, well, the transcripts are awesome. We thank both of them. And I actually heard the other day that some people would listen to podcasts, but they don't because there's no transcripts for them to search for the part that they're interested in, which I thought is interesting, is that like having transcripts actually probably increases the listenership because a lot of folks don't have the patience to listen to all 60 minutes. They just want to search for KDB plus and go straight to that one thing. But yeah, with that, I guess we'll say once again, thank you, Ashok, for coming on. This has been awesome. And we'll say happy array programming.
Happy array programming.